Mehta sir, good afternoon.
Good afternoon, sir. Good afternoon.
So, shall we start, sir?
Let's start after 3 minutes because there are less participants are there.
Okay, sir.
Let's start at 2:10. Okay, I'll start at 2:10.
Okay, sir. Okay, sir. You straight, you can start, sir. No issue.
Okay, sir. So we are starting the session. Can you see the SPSS file, all of you? Hello.
Yes, sir. It's coming, sir.
Yeah, fine. So yesterday we had talked about independent sample t-test. And we had seen that we can carry out this analysis only when the two groups are completely different. Now, the family of t-tests consists of 3 tests. One is one sample t-test, another is independent sample t-test, and third is dependent sample t-test. Now, if I talk about this company, say for example, the CEO of this company has claimed that on an average, we are giving $40,000. On an average, we are giving $40,000. So there is a claim which is there, and we want to test that claim. So first of all, we will write down the null hypothesis. Okay. Now you must have faced some problem that there are some books in which they write null. Okay, null in this way, that mean population, mean of the sample is equal to the population of the sample, right? Or they also write null as x is equal to mu, they write this way, or null is written as x is not equal to mu, or mean of the sample is not equal to the population, sorry, mean of the population. Here also it should be mean of the population. And remove this. Now, which is the correct one? If I say A, B, C, D, which is the correct one? Which is the correct one? And wants to talk to with me? A. Okay. This confusion happens many times because some write in some format, some other write in another format, right? A. Okay, I'll give you one more example. There is the advice which is written on the door. Okay, the advice is ring the bell before entering the room, and there is a second advice which is written on second door. Okay, don't enter the room without ringing the bell. What is the difference between these two advice? What is the difference between not sounds positive or negative? Does it convey the same meaning? Does both of them convey the same meaning? Yeah, fine. Now see, now pay attention. If I write the interpretation of null of the first one, it means that I want to say that the means of sample and population are equal. First one. Same way, this also is true. The means of sample and population are, so it is written in mathematical format. Now, if I talk about the third one, there is no difference in means of sample and population. Is all four things one and the same? Say yes or no. Is it same? Does it convey the same meaning? Yes. So now never get confused. Write it down. Please write down this thing in your books. That it conveys the same meaning. Okay. So there is a claim by the CEO of the company. And whenever there is a claim, we test the sample mean with the population mean. So our HO is, the claim of the CEO is, on an average, we are giving $40,000 as salary. We want to test this claim. So HO is equal to my X is equal to $40,000, or there is no significant difference in sample mean and population mean, right? We want to test this claim. So what was a rule of thumb? The rule of thumb was, if the p-value is less than 0.05, we reject null hypothesis. And if p-value is more than 0.05, we fail to reject null. Right? Let us go in SPSS, analyze, compare means, one sample t-test. One sample t-test. Now we want to test the sample with the population, 40,000. Click OK. And anybody can tell me the interpretation? Anybody can tell me the interpretation? Anybody can tell me the interpretation? The interpretation is, as the p-value, this p-value is less than 0.05, we reject null. It means that there is a significant difference between the claim of the CEO and the sample mean. So the sample mean is $34,000 and the population mean is $40,000. Okay. Please confirm, are you getting the result? Yeah, see, you will not be able to click OK until and unless you feed the value of $40,000. Then only the OK will get activated. Right? See, let us try to understand this concept in a different way. Okay, in a very different way. No need to worry. I'll explain why it is not happening. Okay, share your screen. Anisha, who is it? Anisha. Anisha, please share your screen. What's the problem which you are facing? Anisha, share your screen. Anisha, please share your screen. Okay, you are on phone. If you are on phone, then how you will be able to, how you are running SPSS?
Sir, hello? Hello? Hello?
Yeah, I am listening.
Sir, I am on phone. I have opened the Zoom on phone, but I'm doing it on laptop. It is with me only. SPSS is on laptop only. Sir, I'm not able. I have pasted 40,000 on it, but it is not showing. I mean, the OK button is not activated.
Do take the screenshot and put it in WhatsApp.
Okay, sir.
Quickly. Okay. Till that, let us understand the concept. All of you, please pay attention. What is the whole concept? Why we have not understood the one sample t-test properly? Can you see my Excel file, all of you? I'm sharing the screen with you. Can you see the Excel file now?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now, just tell me, have you seen any product on which the population mean is written? Anybody has seen any product on which population? Is there any product on which they write the population mean? Say yes or no in the chat box. Is there any product on which you get the population mean? Aruna Ganu says no. Anybody who wants to answer this? Ruby Das says no. Come on, give your opinion. Any product which writes the population mean. See, this is a root level knowledge of statistics which you have to imbibe in yourself. That where will I get the population mean? Run t-test, very simple. But how will I get the population mean?
Sir, we have to find out the fiduciary limit.
Exactly, Baden Bora. I want to explain the same thing. What is population mean and sample mean? That's what. Running the analysis is very simple in SPSS, but what we are doing, we have to understand. Yes, somebody was answering this.
Sir, we have to find out the fiduciary limit for population mean.
No, is there anything which gives the population mean? Anything, any product? Do they give it or not? Do they disclose the population mean or not?
No, sir.
They do not disclose.
100% product disclose the population mean. 100% product they have to disclose. All your FMCG which they write that this product contains 100 gram, that is population mean. Is it clear? It is their standard they are writing. Now let us understand that the product has claimed that our wafer packets consist of on an average 100 grams, right? But you were quite skeptical in this matter, right? You were quite skeptical in this matter. And therefore you said that I feel that there is some dubious thing which is running. I'm not sure that they are giving 100 grams or not. So what you will do, you will randomly select some packets from different parts of the city and you will start weighing them. So you start weighing the first measure, 99, 98, 101, 102, 97, 99, 98, 99, 100, 101. Say, for example, you selected the 10 packets. Okay, be with me. Yes, good afternoon, Lakhajat. Good afternoon. Now, what you will do, you will take the average of this and enter, right? Average of this and enter. So how much did you got here? 99. This is your sample mean, right? This is your sample mean. And this is your population mean. Somebody was asking me yesterday that what is the difference in one tail and two tail. So your sample mean is 99.22, right? Is it clear, all of you? Any doubts now?
Yes, sir.
Any doubts? Yes or no?
No, sir.
Now, do you think that the difference between these two is very large? Do you think so?
No,
No.
sir. No. So sample mean is less than population mean. This is one tail.
Agreed. No. This is not one tail. This is not a one tail. This is not. I'll give you the concept of one tail. I'm just trying to explain you. B13, that is a sample mean minus the population mean, E13. Will you claim that the wafer company is doing some gimmicks with us? The difference is 0.78. 0.78 gram difference. Will you do it or not?
No, sir.
No. Okay. Now, in one packet, I got 90 gram. Now, will you say that the wafer company is doing some gimmicks with us or not? 1 gram difference.
Yes, sir.
Okay.
Yes, sir.
95 grams. 97 grams. So there are some decisions. If here the difference is large, you are in the position to tell the things clear cut that, yes, Aruna Gano, I'm coming to that only. Aruna Gano has written down things very nicely. We are coming to that part only. Now, let us understand this concept in another way. $100 gram is the population mean, right? What is the possibility that a wafer contains only 50 grams? What is the possibility? What is the possibility that it contains 50 grams? Half?
50% possible.
Very, very less possible.
Very well. Okay. What is the probability that you get 150 grams?
That too also very less.
So as the probability of the occurrence is on both the sides, it is a two-tailed test. Okay. Now, as you approach nearer to 100, you will get the bell-shaped curve. Clear, all of you? Is it clear?
Yes, sir.
Now, pay attention. I'm trying to explain the entire concept of rejection and acceptance. This is your population mean. Okay. Let me draw it more nicely. This is your population mean. Okay. And say, for example, this is your sample mean. Right? So this is your mu and this is your x bar. So I want to, please pay attention, all of you. I want to find out the place where I will say that there is a significant difference between these two. Please pay attention. I want to find out the place from where I will say that there is a significant difference in x bar and mu. So what will happen when I'll do the sampling? If I'll take another 10 samples, it may be possible that I get the mean here. If I again take another 10 samples, it may be possible that I get the mean here. So my mean will constantly get fluctuated, right? But I want to find out the point where I will say that there is a significant difference in sample mean and population mean, and the company is doing some gimmicks with us. So I want to have a strong fencing. Okay, a very strong fencing is to be done. So I'll select now another line. One, copy. And first of all, let me check this and make it green borders. And let us make this a thick borders. And here also I'll copy it, Control V, and these are also the thick borders. Now I want to do the fencing. Now please pay attention to this again. This part. See, please listen to my words. As this cursor is moving, there is no significant difference in sample mean and population mean. Yes, true, 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 true. But as soon as I cross this, there is a significant difference in sample mean and population mean. Similarly, here also, there is no significant difference in sample mean and population mean. True, true, true. But when when the difference is large, I will say that the difference is significant. So it means that whatever fluctuations which are happening in between, that sometimes you are getting 98, sometimes you are getting 99, they are all tolerable fluctuations. And here the fluctuations which are happening, they are because only of chance element in this zone. It is because of chance element. But if there is an extreme fluctuation which is happening in the sample mean and the population mean, means I'm talking about this, you are in the zone of rejection. It means that you reject your null hypothesis, that the difference is very large. And here you accept the null hypothesis, or in other words, you say you fail to reject null hypothesis. Now, when there is a rejection, there is a reason that why this thing has happened, why there is so heavy fluctuation which has happened. So there is a reason. Here, there is no reason because you are accepting the null or fail to reject null. I'll give you another example. Suppose your child is on an average getting 60 marks. Okay. So this year he got 61. Will you do some inquiry? Will you ask? Will you do some investigation? No, you will not do investigation. You will say more or less his range is 60 to 61 only. Or he gets 59. You will not do any inquiry. But suddenly, out of the blue, that instead of 60, he got 20%. Will you do the investigation now? Say yes or no.
Yes, sir.
Or he gets 90%. It is a surprise element for you on both the sides. And how come he got 90? Right? So you start searching for a reason that what has gone, what is a thing which has changed, right? Now the question arises that this fencing, how we can do this fencing? What should be the criteria for doing this fencing?
Probability 95% or 99% like that.
Right. So yesterday we had talked about this in length, that we are working on 95%, and therefore this length is how much? That if we consider x bar plus or minus 2 sigma, 95% observations will be there inside, right? 95% observations will come into this. Is it clear? All of you say yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Still you are not clear with this. I can throw more light on it. That what is the relationship of 95% and 2 sigma? Do you want to know the relation?
Yes, sir. Yes, sir.
Okay. Okay, go here, all of you. Sorry, this is let me take this one. Just a minute. Let me take this one. This one. Yeah, this one. Can you see that table? Just a minute. Where is the table gone? Yeah, can you see this table, all of you?
Yes, sir.
Yes, sir.
Okay. The concept here is that we should work on x bar plus or minus 2 sigma, right? So if I want to include 95% of observation, be with me, 95% of observation, I'll be giving my verdict on the basis of 95. So 95 will be divided into 2. How much is it? Please write down on one page. How much is it? 95 divided by 2. How much do you get? 47.5%. Okay, 47.5%. Okay. Now go in this table, right? And try to locate where you are getting 47.5. You are right. 47.5, right? And if it is just a minute, huh? Let me confirm. It is 0.9744 into 2. Yeah. So just see this value, all of you. Just see this value at 1.96. How much is this value? 0.9750. So how much is the error? 2.5%. It is at what value? 1.96. See this value 0.9750. See this value 0.9750. Right? So instead of working on 1.96, the academicians say that we will consider plus or minus 2 sigma, where 95% observations will come inside. And that is the whole concept of working on plus or minus 2 sigma. It means that 95 will be there and the rejection zone will be 2.5% this side and 2.5% this side. Now, let us come back here on our original example. There is a claim that on an average 40,000 we are giving. So 40,000 is a population mean. The sample mean will come from this employees. And you can see the p-value here. Now tell me what is your interpretation? Now it is clear. What is the interpretation? What is your interpretation? Please tell me.
As T statistics is minus 7.115, is 0.00. This is less than 0.05. Level of significance.
Okay.
So we reject null hypothesis and conclude that company
there is a significant difference between the claim of the CEO and the original salary which is drawn. Okay, so the CEO of the company was warned that, sir, you are saying the salary on the higher side. We are not paying so much. So next time when he was again addressing the meeting, he changed this to $34,000. All of you, please change this to $34,000. Change this to $34,000. Click OK. Now anybody can interpret the result for me.
So we fail to reject a null hypothesis.
Yeah, we fail to reject the null hypothesis. So it means that the claim of the CEO is correct. Now again a meeting was called and he felt that again I am saying 34,000 on the higher side. And therefore, this time he said $25,000. Now, what is the interpretation? What is the interpretation? Failed to accept null, Deep Jyoti Chakravarti. We never use such word, Deep Jyoti, failed to accept null. We fail to reject null. No, Manisha Goswami, we reject null. Saudar Alam, you are wrong. Saudar Alam, we reject null because p-value has gone below 0.05 in third case. 3 cases are there. See, the first case. 34,000 salary is here. And the CEO claimed 40,000 on higher side. So when it was on higher side, your p-value became significant, less than 0.05. And here when it was 25,000, again it became significant. right? Is it okay now?
Sir, one clarification. I want to know from you. So 34,000, is it sample mean or population mean? Which one is population mean here? 40,000 or 34,000?
See, what you are getting this answer, no, this one, this mean 34,490.
This is a sample mean.
This is a sample mean. Right? Shall I proceed further? Any doubts are there? Please ask.
So less than the population mean.
Right. Any questions are there? Any questions are there? Shall I give you another example now?
Yes, sir. Please give another example.
Okay. On an average, in our organization, people have studied up to 12th standard. Okay. Now what you will do? What is a claim? Or still there is one more example. On an average, employee in our organization are holding an experience of 100 months. Okay. Now what you will do? 100 is a claim of the CEO. Say yes or no.
Yes, sir.
Yes,
Yes,
sir.
What will be the null? What is the word which you will use? There is no significant.
no significant difference between
in
the
the
claim of
between the sample mean and the population mean. Okay. Or you can also write that the claim of CEO is correct. But technically, statistically, you will write there is no significant difference in sample mean and population mean. Okay. So analyze, compare means, one sample t-test. I'll drop the salary here. So what is a claim? 100. So 100 is a population mean and whatever will be computed is a sample mean. Click OK. Come on, anybody can tell me if the claim is correct or not?
We fail to reject null hypothesis.
Which means what, sir?
The claim is incorrect.
See why you face so much problem. Let me write the things technically. Okay, I'll remove this. First we'll write null. Null in one sample t-test is always sample mean is equal to the population blindly. Okay, or we say there is no significant difference between sample mean and the population mean. Is it clear? Right. So null is equal to x bar is equal to mu. Right. Now let me take this control and let me take this output. You can export this output as one sample t-test and paste it here. Now see, you have to see the p-value, this p-value as the p-value of t statistics minus 0.862 is 0.389, which is greater than 5% level of significance. Come on, what we will write? What we will write?
we accept null hypothesis.
Fail to reject.
We fail to reject. At the back of the mind, you can remember that it is accept. At the back of the mind, but don't write in the research paper. We fail to reject null, which means that there is no significant difference in sample mean. How much is a sample mean? 95.86 and population mean, which is 100. And so we can say that claim of CO is correct. Clear?
Yes, sir.
Please write it down. Done? Have you written it down?
Yes, sir.
We are not seeing the p-value, this p-value, because it is for other current salary. We are just seeing the p-value of this one, right? Okay. Now I will show you one PPT. What is the difference between one sample t-test, dependent sample t-test, this is your normal distribution curve, right? So these are the students which are located at the distance of plus or minus 2 sigma according to their height. Now, any observation which is beyond plus or minus 3 sigma is considered to be outlier, right? Or we reject it, that your extreme fluctuation is there. So in this, you can take this screenshot for lifetime. If p-value is less than 0.05, you are in this red zone, you reject null. Fluctuations are due to the assignable causes. New theories are true. Something has changed. Here, p-value is more than 0.05. You fail to reject null. Fluctuations are due to the chance causes. Old beliefs are true. Nothing has changed. Here also, the p-value is less than 0.05. We reject null. Fluctuations are due to assignable causes. New theories are true. Something has changed. Right? Is it clear?
Yes, sir.
Yes, sir.
Now, again, my question goes back. The thing which we should prove, it should be null or it should be an alternative. We want to prove it should be null or alternative. Tell me.
It may be anything, sir.
So the answer is, you cannot have such concept that what we want to prove is alternative. No, that is completely a wrong concept. It's a myth. It's a myth. Now let us understand that in some cases we are interested that the null gets accepted or we fail to reject null. Global warming is not due to the pollution. Global warming is due to the pollution. Now here, in this case, we are interested in which hypothesis that it gets accepted. You tell me.
Alternative.
Alternate.
Alternate. Okay. The second hypothesis. There is no significant effect of corona on economy. There is significant effect of corona on economy. Here we are interested in what?
Alternative.
Why alternative? If I talk about two parties, first of all, there is a disclaimer from my side. The first disclaimer is I don't belong to any political party. Okay. Any of the lecture don't talks about any of the political party. Second disclaimer is I don't do marketing of any software because I speak on many softwares. So this is a disclaimer from my side. Now let us talk about a foreign country that there are democratics and other is republic. Okay. One of them will say that the effect is there because they want to hamper the government, and another will say that there is no effect. Got it? So one party is interested here that there is no effect. We are doing extremely well. Things are doing marvelous. Other want to say that no, there is an effect. You have not taken enough measures. So just understand that being a null or alternative, what to accept is completely dependent on what is your problem statement. You can never blindly say that the thing which we want to prove, we will put in alternative. Is it clear? Sometimes we are interested in null. Sometimes we are interested in alternative. Right?
Yes.
Do you want to have an example where the scientist continuously failed for 10,000 times and he proved that this cannot be made, that there is no relationship of this with this? Do you want to know the name of this person? Anybody? Anybody? Come on, tell me. Yeah, it was Thomas Alva Edison. Right, Kailash Podwal, right. Then he was Thomas Alva Edison. And every time his null was only accepted. That there is no relationship of generating the electricity with this. 10,000 times he failed. And the alternative was accepted after so many times. But what his conclusion was that in research, no result is also a result. It means that we are having so much affinity that our p-value should be less than 0.05. Then only the result is meaningful. Is completely wrong thing. You can have the result on both the sides. Consuming the Coke increases the blood pressure is also a research. Consuming the Coke does not have effect on blood pressure. That is also research. Those who are coming from finance background, they know this, that there are two models, Walter and Gordon. They have said you pay the dividend or you don't pay the dividend. It has got effect on share price. So here alternative is working. If you talk about model, Miller-Modigliani model, he says you pay the dividend or you don't pay the dividend. There is no relationship of this with the share price, and here null was considered. Is it clear? So friends, don't have so much affinity towards p-value. There is an article, very beautiful article written, p-value ghost, the ghost of p-value. Okay, a ghost story by Anish Shah, p-value. Please read it, right? That what is so detrimental about this p-value. So don't have so much affinity for it, right? Still, there is one more article also. The first ghost of experimental, it is either significant or noise. Any questions are there, please ask. Shall I move to the next level now? Shall I move to the next level?
Yes, sir.
Yes, sir.
I hope things are getting clear now.
Yes, sir.
Okay. Now, what is the concept of one sample t-test? Let us understand. If there is no probability of happening on event on lower or upper side, okay, lower or upper side. What do I mean to say is that suppose there is a claim by the company that on an average, our bike gives 65 km per hour average. Okay. Do you think that now your bike, which you have purchased, will get the mileage more than 65? Do you think will you get it? The company has claimed 65. Will you be able to go above 65?
Yes, sir.
Will you be able to go above 65?
No, sir.
The company has in idealistic situation said that on an average, the bike will give the mileage of 65. Will you get the mileage more than 65? No way. And therefore, all your observations will be on one side now. The things will be on one side. And this is what is known as one sample t-test. So your null is either it is equal to 65 or the alternative is it is less than 65. So how do I write the null? I write the null this way here. In this case, my null will be that my x is equal to 65 or alternative is x will be less than 65. And here we are using one sample t-test. And here we will be using the p-value, which is half of 0.05. And therefore we'll consider p-value to be 0.025. Right? Now the case of greater than. Now the case of greater than. The minimum size of the bamboos is 5 feet. Is 5 feet. Will the bamboos be more than this 5 feet?
Yes, sir.
Yes, sir.
It will always go above 5 feet. Say yes or no.
Yes, sir.
So here our null is either my x is equal to 5 feet. Alternative is
X is greater than 5.
x is greater than 5 feet. One sample t-test. P-value 0.025. Please write it down. Write it down. Done?
Yes, sir.
Okay. Now see this PPT, all of you. See this PPT. In one sample t-test, from the population, we are extracting the sample and the sample mean is compared with the population. And the null is there is no significant difference between population mean and the sample mean. This is one sample t-test. If I talk about independent sample t-test, we are comparing the means of two groups and both the groups are different. Male, female, urban, rural. And what is my null? There is no significant difference in means of two groups. Got it?
Yes, sir.
See, both the groups are different. Please pay attention, all of you. Please pay attention. Okay. First one again. Sure, first one again. See. Just see that these three are part of this whole population. 1, 2, and 3. Deliberately, I have taken the screenshot this way. That yellow, green, these are all part of the population. So from population, I'm extracting the sample and I'm trying to compare the population mean and the sample mean. Right? So 1 kg, we are giving 1 kg in our team. That is a population claim by the company. So you take 100 containers of ghee from say different locations. You compare this weight and compare with the population mean. So sample mean and population mean. Is it clear?
Yes, sir.
Yes, sir.
Shall I proceed further now?
Yes, sir.
Yes, sir.
Okay. I will ask straightforward question. Who is getting confused? Please tell me that we are getting confused. Anybody? Anybody feel free to discuss with me. No? No? Anybody who is getting confused, feel free to discuss with me. No. Fine. Now see this part again. If I talk about this, right? This is mu. And this is mu will not change because it is a claim. This is a mu 100. And this is x. Okay. So our story was that when x comes exactly here, right? And when it crosses, then we reject the null. So what I wanted to say is that when the distance of x is greater than 2 sigma, we will reject the null. When x is 2 sigma away. Okay. So let me write down this equation as x is at the distance which is more than mu plus 2 sigma, right? 2 sigma. We will say that the difference is very, very large. Is it clear, all of you? Is it clear? Say yes or no. X has gone beyond the fencing. It has crossed the border. Okay.
Yes, sir.
So suppose if I say that if I change this and I make this as x minus mu divided by sigma, it should be equal to 2. And if this is more than 2, we will say that the difference is large. So x bar minus mu divided by sigma is equal to 2. If this difference is more than 2, we will say that you have entered into the rejection zone this side or this side. So this means that there is truth 1 minus truth 2 divided by standard deviation. It means that things have changed. Right? Now, what is a dependent sample t-test? So it is an extension of one sample, and what the things are changing, let's see. In one sample, in independent sample t-test, we are comparing two groups. This is the first group, 1, and this is the second group, 2. If the distance between these two groups is more than 2 sigma, we will say that the difference is very, very large between these two groups. So here groups are different. In case of dependent sample t-test, we are comparing the same group before and after the treatment. And we want to say that is there any significant difference between these two or not. Remember, the participants in dependent sample remain same. I'll show you the example. Just see before and after. And what do we write? Null. There is no significant difference in means before and after the treatment. Clear? Any questions are there? Please ask. Any questions are there? Please ask. Any questions? No? I hope you are all listening.
So treatment here means?
Treatment
Can you
means,
give an example of dependent sample t-test?
definitely. See on the screen. Before, after. You are somewhere around 100 participants. So I had told Dipankar sir that take their knowledge, take their MCQ, the knowledge of SPSS before joining this workshop, and take their test on 20. Just I'm giving an example. So somebody got 10, 11, 12, 9, 15, 11, 8, 9, 7. Now, after our workshop was completed, your knowledge of SPSS was again taken down. 40, 30, 40, 18, 16, 13, 12, 10, and here it is 12. Now, I want to say that is there any significant difference or not? So I will take the average. Okay, average 1. So this average was 10.10. This is 13.56. right? Now, if you are listening to my lecture very carefully, how much should be this difference? This difference should increase by how much? A11 minus B11. The difference is minus 3.33. This difference should be greater than what? Tell me.
3.
This difference should be greater than. This difference should be greater than. This difference should be greater than
2 sigma.
2. Just simple, because we are working on 2 sigma, and therefore this should be greater than 2. If it is greater than 2, you will say not 0.5, greater than 2. See here, 0.5, we are working here. 2. This difference should be 2 sigma. Okay. So when we will get 2, definitely I will divide this by standard deviation. And if it is more than 2, I will say that yes, something has changed and the participant has gained the knowledge. Okay. What will be my null? Null is, again, the onus is on me only, that prove it that your SPSS workshop was trustworthy or it was meaningful. So you are all sitting with the defense wall, and the defense wall is there is no significant impact, or there is no significant difference in knowledge of the SPSS in the participant before the workshop and after the workshop. Okay. And you are asking me that give me the proof. So I am giving you the proof that this is a proof. We will go ahead. Now in our data set, tell me the 2 variables on which we can carry out the dependent sample t-test.
Salary and beginning salary.
Yeah, salary and beginning salary. So what will be our null?
There is no any significant difference between
in the current salary and the beginning salary.
beginning salary.
Okay. So go in analyze. Compare means paired sample t-test. Okay, what will come first? Beginning salary or current salary?
Beginning salary.
Beginning salary.
Or hardly matters?
Hardly matters.
It hardly matters because we are working on difference and therefore it hardly matters. But while time of interpretation, you have to be very, very careful. Careful in the sense, interpretation will remain same, but there will be a negative sign which will be introduced. Okay, first we'll run the analysis with salary begin and then salary. Run the second analysis with salary first and then salary begin. Click OK. Now see the p-value.
It's less than 5%.
So what does it mean?
We will reject the null hypothesis.
Very nice. We will reject the null. It means what?
Means there is a significant difference between
Right. There is a significant difference between current salary and the beginning salary.
salary.
So on an average, how much is the difference which I am getting? Apart from this mean, all other statistics will remain same. You see, everything remains same. So you have to be very cautious in the matter that this difference will indicate the increase also and decrease also. But you have to pay attention here. Beginning salary minus current salary is negative. It means what? Which is more?
Current salary is more.
Current salary is more. The same thing when you say current salary minus beginning salary, same number, but with the positive. It means that on an average, the rise in the salary of each and every employee is by $17,000. Clear?
Yes, sir.
Is it clear?
Yes, sir.
Do you want to run the t-test for this live example which we have done? Do you want to
Yes,
run
sir.
for this? Okay, let us run it. And one thing which is there on our cards is to do the entry of the data in SPSS. Anyway, all of you go in File, New, Data. Right? Go in Data. Go in Variable View, and enter before and after. Enter it. In variable view, huh? Not in data view, in variable view. Done?
Yes, sir.
Now, please copy this data. Okay, you will have to enter it manually. Go in data view and enter it manually. Come on, 9 entries, do it on your own. From data view, you will be able to do it before and after. Do the manual entry. Done? Is it done? Okay, anybody wants to wait for me? Anybody wants to wait, or shall I proceed?
Proceed, sir.
Okay, please write the null of this. What will be the null? See, I can write the null in so many ways. First, there is
No
no.
significant difference between the beginning salary and the current
No,
salary.
it's not a salary. It's a knowledge of SPSS. There is no significant difference in
MCQ.
knowledge of SPSS
Before and
before,
after the treatment.
after the workshop. I have not given you.
Yes.
Alternative is there is a significant.
Significant
There is
difference,
a significant difference.
in knowledge of SPS.
Okay, I can also write workshop was not successful. Or here I can write workshop was
Successful.
okay. Where I'll go? Analyze, compare means paired sample t-test before and after. Click OK. Anybody can interpret the result?
Null hypothesis is rejected.
Which means what? I will
Yes.
write. I will write as
p-value is
of the
0.0.
t statistic, as the p-value of t statistics, which is 3.922, is 0.004, which is
less than 5% level of significance.
we reject,
The null hypothesis.
which means that
There is a significant difference
in the knowledge of SPSS of the participant.
before and after the workshop.
Okay. On an average, the knowledge has increased by how much score? The knowledge has increased by
13. No,
how 13? Where is 13? 3.33.
3.3. Yes.
3.33 minus 2. Okay.
Minus it is because it is before and after is more, and therefore it is minus. Okay. Shall I proceed further?
Yes, sir.
I hope you are all not tired today.
No, sir.
Shall I proceed further? Any clarification on the previous thing? No?
No, sir.
Okay. Now we will increase the level. This is one-way ANOVA. And in one-way ANOVA, we are comparing more than two groups. See, all the three groups are different. Can you see?
Yes, sir.
Okay. All the three groups are different. Right? Now, you tell me, what will be the null hypothesis if, okay, you tell me that which are the two variables in which I can run the ANOVA. You pick up the variables.
Education.
Okay. Anything else?
And this job category.
Job category with
education.
Job category with education, both are categorical. It will go in chi-square.
Okay, no, continue.
Gender and education level. Education.
Gender and education level, if you are working on it. May I know who is it? Hello. May I know who is it?
Salary.
So who said that gender and that
It's Bidhan Bora side.
yeah, what was your example? I forgot it. What was your example? Gender and
this education level, I think.
Gender and education. See, gender, the grouping variable is again two, male and female. Why you should go for ANOVA? Your grouping variable should have more than two categories. Yeah, fine. Salary and education, you can do it. But still there is one more.
Job time.
No, job category and salary. See, this is categorical and this is continuous. And in job category, there are three categories: clerical, custodial, and managerial. Okay. So what will be my null? Please help me to frame the null of ANOVA. Just a minute. I'll open the ready reckoner so you will not get the confused. So where is the ready reckoner? Yeah, here the ready reckoner is there. We are using one categorical variable and one continuous variable, and the words should be, difference should be there. and therefore some words are default, which I'll write down, no significant
Difference.
difference. Now frame it.
There is no significant difference between job category and salary of workers.
No.
There is no significant difference. At least one of the variable.
No.
There is no
There is-
significant difference in salary according to job category.
Right, according to job category. Right. Now, what will be alternative?
There is significant difference.
There is significant difference in salary according to the job category. This is your alternative, ma'am.
Yes, sir.
If it was so easy, I would have never asked it, ma'am. Okay, there is a twist in the story. Biren Bora.
There is a significant difference in salary according at least
No.
at least
Yeah.
at least in one job,
I heard you. Yeah, I heard you. At least, so I heard you.
Yes, sir.
Sir wants to say here. At least one pair, if he is having a difference, okay, at least one pair means this pair compared with this pair, this compared with this pair. If any one pair is also significant, no, your ANOVA will become significant, right? And therefore, the alternative is little bit tricky in case of ANOVA. You don't write such thing. You will write there is significant difference in at least in salary of at least one pair of job category, right? Is it clear?
Yes, sir.
Anybody who is facing a problem? Anybody? Shall I proceed further? Anybody who is having an issue with this? No?
No, sir.
Later. Okay. Kailas Podwal is having an issue. No need to worry. Kailas ji, please pay attention here. What our concept is. We are having three pairs. A compared with B, B compared with C, and A compared with C. And here ANOVA is there. If I frame my null, if I frame the alternative is there is significant difference in salary according to the job category. If I straightforward write like this, it means that your ANOVA will be significant only when this pair is significant, this is significant, this is significant, and this is significant. Then only your ANOVA will become significant. But if I write according to at least one pair, then even if one of them is significant, other are not significant, then also your ANOVA will become significant. Any one pair. Any one pair. This is not significant. This is not significant. Significant, not significant. Significant. Is it clear, Kailas ji? Is it clear? Now, please write in chat box. Okay. Fine. Let us go back in statistics. Analyze descriptive statistics. No, compare means one way ANOVA. Our target variable is salary. And job category. go in post hoc and click on Tucky. Click continue, go in options, click on means plot. Continue, click OK.
Sir, options, what did you click? Means plot?
Yeah, means plot. Done? Okay. See the p-value. Just see the p-value, all of you. First of all, take it to file, export, and save this as ANOVA. I've saved that t-test also anyway, it's fine. I activate this ANOVA. I'll remove all other things and I only want to focus on and I'll copy this null hypothesis there. Okay, anybody can interpret this thing for me? P-value less than 0.05.
So at a state we can reject a null hypothesis, but if you go to the post hoc analysis, then we can say the differences in different categories of job.
Yeah. So difference is large, right?
Yeah.
So p-value is less than 0.05. It means that the ANOVA test is significant. Now, if the difference is there, it is between which two categories? So here clerical is compared with custodial, clerical compared with managerial. Custodial compared with clerical. Now see, clerical compared with custodial and custodial compared with clerical, they are one and the same thing. The signs are reversed. Please find out the pairs, unique pairs, okay, not reversal, unique pairs whose p-value is less than 0.05 and post it in the chat box that the difference is large in between these two pairs. Find out the pair and post it in the chat box. So there are 11 answers which have came up. Manager and clerical pair, clerical and managerial, custodial and managerial, very nice. If you'll scroll below and you will be able to see the means plot. See, there is no significant difference in mean salary of clerical and custodial. They are very much nearer to each other. But the difference between clerical and manager is large, custodial and manager is large, which we can confirm by the difference also and the p-values. Is it clear? Is it clear?
Yes, sir.
Shall I proceed further now? Say yes or no. Shall I proceed further? I hope you are not tired or you want to stop here. Just write down your answer. We will go by the majority. Repeat once again. Okay. See, we have calculated the mean of clerical salary, custodial salary, and managerial salary. And we wanted to check that the difference is large or not. So when clerical compared with custodial, the p-value is more than 0.05 and we will say that the difference is not large. 3,100, the difference is not large. But here the difference is large between clerical and managerial. $36,000 difference is there, and as the p-value is less than 0.05, we confirm that the difference is very large. Post hoc test is this Tucky test is post hoc test. It is the further dissection of the ANOVA that if the difference is there, it is between which two pair, and that's the reason we carry out the post hoc test. Okay. Any questions are there? Please ask. Any questions are there? Please ask. Shall I go to the next level? Kindly write your answer in the chat box. Yes or no? Yes. Okay. Now pay attention here again. At present, we have compared the salary of clerical, custodial, and managerial. But I want to also see the effect of male and female. That is the effect of gender, right? And here, job category. Right? Now, how many hypotheses will be framed here? You tell me. How many hypotheses will be there? How many null hypotheses will be there?
3.
3. How 3?
Two, sir.
2. Okay. 2. Somebody says 3. Somebody says 2. Somebody says 1. How many null hypotheses will be there?
So for clerical it is 1, for custodial and for managerial.
No, that will be the single hypothesis. This is 1. This entire thing is 1, right? So let me try to develop this thing in multiple graphs so that you can understand what is actually happening. We are in the zone of two-way ANOVA. Okay, so my null hypothesis will be, this is my first null, and I'll write down 1, null 1. And I will highlight the feature as we are going to run the test like this, and I will give this as, sorry, not as yellow. Let me see from where I can pick up the colors of this one. So this is a test which will run like this. Then comes the second null. There is no significant difference in the salary according to the gender. And here, this test will not run like this. It will be working. We'll be running this test like, sorry, the test will be, first of all, let me remove this one. Right? Second. Then there will be third null. There are no interaction effects. Here again, I'll take this, copy, and it will check the things overall. So this will include everything here, and I'll make this as blue. Is it clear? Take the screenshot. This is a difference in two-way ANOVA. Okay, I'll give you an example to this. That there are 3 sections, A, B, and C. And the teacher 1, teacher 2, teacher 3. And these are the marks of the students which are recorded. So first is, there is no significant difference in marks of the students according to the section. 1. There is no significant difference in marks according to the teacher. And there is no significant effect of, there is no significant interaction effect. It means that particular teacher, when teaches in particular section, and does it get more marks in comparison to the other teacher who teaches in another section? Okay, so we are comparing that way also, right? So this is an interaction effect. So for this, where we will go? We will go in analyze, GLM, univariate. Done. GLM univariate. Click on it. Now your dependent variable is salary, and you will include gender and job category here. Model is full model, contrast is plots. Necessary post hoc, gender and job cat. Click on Tucky. Post hoc, gender, job cat. Continue. Click OK. So let us break these things one by one so that we can understand. First one, okay? First one. Is output visible to all of you? Say yes or no. Is output visible? Hello? Hello?
Yes, sir.
Okay. First of all, I'll talk about this much part only. The p-value is less than 0.05. Is it significant? It means that job category, is it affecting the salary? Is the difference is there? Say yes or no in the chat box. This much component.
Yes.
Yes.
Okay. Let us go back in the output window. And now this time only gender. Is it significant?
Yes, sir.
Yes, sir.
Okay. Let us go in our again this one. Interaction effects. Particular gender working in particular job category. His salary with gender, other gender in other job category. Is it significant?
Yes, sir.
Yes, sir.
This is two-way ANOVA. Now you tell me that you can run two-way ANOVA between which two other variables? We have run. We have taken
education level and job category.
Education job category 2 and the target variable salary.
Salary.
Salary target variable job category
Category.
and minority.
Okay.
So this is your assignment for today, running the two-way ANOVA. Thank you. Over to you, Dipankar sir.
Sir, I have a request for you. Hello, sir. Mehta sir.
Yeah.
So I have attended your earlier workshop also, that SPSS R. I have your this excellent book R with me also. So one might request, can you give some light on PCA in the later part of the workshop? So I am very much interested on PCA, sir. Actually,
Principal component, component.
Modern analysis and factor analysis. If possible, in the later part of the workshop, if you can give you some light on this PCA.
Definitely.
But actually, I joined this workshop because of that only.
No. I'll take care of it. Don't worry. If the time permits, I'll definitely work on it. Oh. Now, please pay attention to all of you. Dipankar sir, are we having a time? 2 minutes, 2-3 minutes more?
Yes, sir.
Okay. Now, it may not be possible for you to attend so many lectures of mine which are going on, right? And I'm sharing my screen with you again. Can you see the screen, all of you? So many screens are opened up. Yeah. See, this is my channel, Dhaval Mehta. Please write it down. Spelling is Dhaval Mehta, DHAVAL Okay, I'll copying it in the chat box. You go in the playlist and you will find 7 softwares which I've already uploaded. Right? Like data science using Python, data analysis using RapidMiner, machine learning, artificial intelligence, time series analysis using eViews 12, data analysis using R and RStudio. The entire lecture series are available. Right? So this is the first method of learning. Another thing is we are completely in the training of softwares only. And the softwares which we teach are there is another person, Hitesh sir is also with me, but I teach SPSS, StatCraft, Jamovi, Minitab, MATLAB, Gretel, eViews, MS, Smart PLS, Edenco, Minitab, Design of Experiment, Design Expert, Atlas.ti, NVivo. This is for qualitative data. Orange for machine learning. This is for design of experiment. RStudio, R Commander, machine learning using RRetel, RCaret, machine learning using Beka, machine learning using RapidMiner, production and operation management using Tora, Gephi, Python with Jupyter Notebook, which includes the following libraries: machine learning on Python with Scikit package, Stata, Tableau, Power BI, Google Data Studio, IBM Watson Predictive Analysis. Some of my books which are available on Google, you just write down data analysis using R. Don't even write the name, okay? Data analysis using R, and go in images section. The first book which will appear is my book, right? It is getting constantly 4 to 5 star rating, constantly. If you want to purchase this book, don't purchase from Amazon.com, purchase it from Amazon.in, okay? You go on Amazon.in. There, the book has been kept at the low price edition. So all those who want to learn about R, so data analysis using R. It is a second book which always comes, right? Sometimes it is first, sometimes it is second. It is costing $734. This book always comes in the combination of my another book, which is machine learning using RRetel. So that is about predictive analysis. If you want to be in touch with me, I'm having a large DM community, that is Dhaval Mehta WhatsApp channel. And you will find many, there are somewhere around 8 to 9 groups in which you are already, some of them are the members. I will share the link today and you can join my large DM network. You can be part of it. The only thing, 3 things are not allowed. I hope you are all listening. Politics, religion, pornography. 3 things are not allowed. If I found doing somebody such things, I will debar you. No good morning message, no good evening message. Only discussion related to research. Okay, because our channel is not for entertainment. It is only research and research. So you can post your brochures. You can post your programs also. I don't mind. But the only thing, we will always talk about research in that group. So over to you, Dipankar sir. I'll start the video. Anybody wants to ask a question, please ask the question.
Sir, can I?
Yeah. Go ahead.
When I click the post hoc option, I have seen other than Tuki, there are many other options are there, like Games Howell and Bonferroni, all those are. So which one to select? Is there any?
Normally, the most celebrated test is the Tucky and SCAFE. Tucky and SCAFE test is more celebrated, but the different softwares have included the different post hoc tests. Like for some example, some Jamovi uses Bonferroni test. Some others are using Gams Howell test. So it is completely upon the researcher which to report. But most of the time they will tell. So no need to worry. Right?
Okay. Actually, in one of my research work, I have used the post hoc test, and there I mentioned that the homogeneity, and depending on the homogeneity value, I have to use whether Bonferroni or Gainsborough.
No, it's fine. You can go ahead with that. No need to worry.
Okay.
Okay. Is there any other thing? Okay. Is there any other thing? So I have posted the link in the group. You can join my group if you want. You can enter anytime. You can exit anytime. There is no compulsion that you have to join. But by joining in the group, you will come to know. You will get the notification for all my upcoming programs. Yes, Dipankar sir, over to you.
Thank you, sir. So hope there is no question. No more question for today's session. Okay. Then, sir, thank you. So see you all tomorrow at 2 p.m. again.
Right. So now 2 days are left. Yes, sir?
Yes, sir. 2 days left.
Okay. So let us start tomorrow with entering the data in SPSS. Right. How you will enter your data in SPSS. Right? Dipankar sir, is it okay?